Hello, welcome to Homework Helpers. I'm Eileen Diggle. I'm a former math teacher from New Bedford High School. My co-host is George Goodfellow, a former science teacher at New Bedford High School, and we're here to answer some of your homework questions. We have a phone number that you can call if you have a question right now. That number is 508-979-1600, and that's the number you'd call between 5 and 5:30 right now while we're on the air. We also have a phone number that you can call later on, and that's something that is 508-979-1760.
And that would be at 5:30 or later.
That's right.
Because once 5:30 comes, we're not live anymore.
Right, exactly.
I mean, we are alive, but we're just not online. I'm sorry.
We're breathing, but we're not alive. We also have an email address for people who would like to email us a question, and that is homeworkhelpers@newbedfordschools.org. And before I turn this over to Mr. Goodfellow, I just want to say that we are brought to you in part by the New Bedford Educational Foundation, and we certainly appreciate their support. And Mr. Goodfellow,
nice job, Eileen.
I think you want to tell us about the rain.
Well, also I want to tell you that we're on Tuesday, Wednesday, and Thursday every week, unless there is no school schedule, in which case there's no program. That's from 5 to 5:30, and then it's rebroadcast at 7:30 at night and 7:30 the next morning. So you can't call in during that time, but if you want to see what you've said or you want to look at the program again, we rebroadcast it 2 more times. By the way, Eileen mentioned that we have a answering machine message, and there was one there today when I came in. Brianna called, but she didn't give a question. So Brianna, if you're out there, could you call back, and I'd be happy to answer your question. We have McKenna, fourth grade, a reading question apparently. McKenna, are you there?
Yes, I am.
Hello, McKenna.
Hi.
What do you got for question?
Well, I was doing my homework in the writer's notebook.
Good girl.
And it came across to the word predicate.
Yep.
So I kind of wrote down the sentence it was in.
Mm-hmm. Can you give us that sentence?
Yes. It is, what chance, if any, could be made in sentence 6 to change a simple predicate to a complete predicate?
Okay, what chance, if any, I'm way behind you. Give me some more.
Could be made in sentence 6.
Yeah.
To change a simple predicate.
Mm-hmm.
To a complete predicate.
Now, the word is complete?
Yep, complete.
It's the words like predicate, and I kind of had a hard time understanding it.
Yeah.
So I wanted to have a way to maybe figure out the meaning.
You know, I'm a math teacher, and Mr. Goodfellow is a science teacher.
Let me give it a shot.
Yeah, good. I'm glad you have a shot.
Let me give it a shot, McKenna, and then if we have some problems, we'll Google it, which is what we do when we get confused. We have a subject, and we have a predicate in a sentence, correct?
Yes.
All right. Now, the subject generally comes first in the sentence, and it's the topic that the sentence will be about.
Okay.
And then the predicate is usually the action that subject takes.
Oh.
Yeah. So if you had a sentence like George rides his horse.
Okay.
Well, George would be the subject, and riding the horse would be the predicate.
Oh, okay.
But what I don't understand is the difference between what they call a simple predicate and a complete predicate. That I'm not quite sure about.
McKenna, do you have an example of a sentence?
Well, I can read the sentence that it was in now because I'm actually looking at it.
That would be good.
Great. What do you got?
It says Laura and Mary waded in the pool.
There you go. Laura and Mary waded in the pool, yes?
And there's one more thing, it says waded as in W-A-D-E-D.
Yeah, that means walking in the water.
Oh, okay.
Like going in up to your knees, kind of.
Yeah. So
yeah, that's what it said. And it said, what change, if any, could be made in sentence 6 to change a simple predicate to a complete predicate?
Well, I would say waded in the pool is the predicate.
sure.
The trouble is, I don't know what you'd have to do to make it complete. I think you're going to have to Google complete predicate, Mr. Woodfellow.
All right, let me put this in, McKenna, and see what we get.
Unless you know. I would say right now, waded in the pool is the predicate. But how to make it go from simple to complete, I'm not
Yeah.
certain. So,
Like, I had my Nana try to help me figure it out, but at the same time, we were kind of confused, too.
yeah,
I think I
well,
might just have...
I'm agreeing with her.
Well, one of the things we do here, McKenna, because nobody can know everything, is we
Sure.
try to teach you how to find the answers as well. So I'm looking on Google right now, and it says a complete, a simple predicate. Many people will listen with interest to facts about bugs. That's a simple predicate. A complete predicate, as an example, many people will listen with interest to facts about bugs. So it looks like a complete predicate is something you expand on. Like this says, Laura and Mary waded in the pool. Well, that would be a simple predicate, waded in the pool. But you might say, Laura and Mary waded happily in the pool. Or waded in the pool until I could no longer walk, or whatever.
You know, I'm looking at the screen there, and I'm thinking that there isn't really any difference between those two sentences. But what it says is a simple predicate is just the verb.
Right.
And the complete predicate is the verb with all the rest of the stuff.
Sure.
So the word waded is the simple predicate.
Well, waded in the pool.
No, just waded. If you notice what's highlighted, it's only the verb where it says simple predicate. And then later, the complete predicate is the waded in the pool.
Yeah, but McKenna wants to take this sentence.
Yeah, but I don't know
and
how you.
expand it.
I don't know why you have to change the sentence. It's just.
Well, that's what
yeah.
her homework assignment is.
I'm not
So
sure.
what I would suggest, McKenna, although we're not totally sure, but what I would suggest is that you take that predicate, you know, the verb and whatever else comes after it, if it's a simple predicate, and then add a little embellishment to it.
Okay.
Walking, wading in the pool joyfully, or wading together in the pool, or add something that defines more about what's going on. And I
Okay.
think you've got a complete predicate if you do that, but we're not positive.
No. Unfortunately, our English person isn't here today.
Yes.
But we
Are
gave
you
it a
okay,
shot
McKenna,
anyway.
with that?
I hope that helped a little bit, McKenna.
Yeah, thank you for your help.
Okay.
Surely.
Bye-bye.
Bye.
Looks like we have somebody else on the line. Elise?
Elise, are you there?
Hi, Elise?
Elise?
Are you still there?
Yes.
What do you got for a question?
Yes.
Oh, what grade are you in, Elise? Elise. What
My
grade?
question is, I came across during my homework the word accumulation, and I didn't know what that meant.
Ah,
Accumulation?
Yes.
Okay. Accumulation, we know the definition of, but do you have a sentence so we can explain that definition?
did they use the word in a sentence in your homework?
It's kind of like we have to memorize a song, and it's for like the water cycle, and it says accumulation, and I didn't understand.
Okay.
Okay.
Then in the case of a water cycle, if they're using the word accumulation, they're probably talking about gathering up the water in different spots.
Yes.
To accumulate means to bring things together, to gather them up, to store them, to pile them on top of each other. Do you know what I mean?
Okay.
So
Like if you put a lot of money in your piggy bank, you could say you were
you're
accumulating the money.
Yeah. So in
Oh,
a,
yeah, that makes sense.
So in the water cycle, there's water on the ground, and then the water evaporates and accumulates in the clouds, you know, and then it comes out as rain and so on.
And it
So
accumulates in the puddles.
Yeah, it accumulates in puddles. So accumulate must mean, in that sense, the gathering up of the water.
Oh, okay.
Is that okay, Elise?
Yep.
Hey, Elise, before you go, what grade are you in?
I'm in 4th grade.
Good job. I'm glad you're studying science.
Thanks.
See ya.
All right.
Bye-bye.
See
Thank
ya.
you.
Bye.
Oh, we
Those
have
are good
another
questions, I
fourth
think.
grader today.
Oh, it's Camden.
Camden.
Hi, Camden.
Hi.
Did you try to call us a couple of days ago?
Yeah.
Oh, I'm so glad you got through because we were worried about you. You have a 4th grade math question?
Yes.
You're going to be so happy because Mrs. Diggle is so good at this. What do you got for a
Let's
question,
hope.
Camden?
The DeMarco family ordered some pizza. Each pizza was cut into 6 slices. They ate 9 slices. In the space at the right, draw a picture to show the fraction of the pizzas they ate. What fraction of the pizzas did they eat?
Good.
All right, I missed a little bit of the detail there. It was something about the pizza was cut into 6 slices?
Yes.
Okay, and what did you say after that?
They ate 9 slices.
Oh, they ate. I wrote the number 8. Okay, the pizza was cut into 6 slices,
And they ate 9?
and they ate 9. There must have been more than one pizza.
What?
There had to be more than one pizza, right? Because you can't eat 9 pieces if there's only 6 pieces there.
Yeah.
Maybe it was the other way, Camden. Could the pizza have been cut into 9 slices and then they ate 6?
No, it says the DeMarco family ordered some pizzas.
Oh, some
Some.
pizzas. I got you. I got you. So every pizza was cut into 6 slices, and they ate 9 slices. And the question is, what fraction of pizzas did they eat? Yes?
Yeah.
Okay, we
Okay.
probably can do that on the Elmo.
Probably be better to draw a picture of it. I
Can we
think
do it
so.
on the Elmo, guys, in the control room?
Yeah.
So look at your TV, Camden.
These are kind of wiggly pizzas, but if they're cut into 6 slices, we could do this. That's 6 slices, right? And then this one's also cut into 6.
Uh-huh.
All right. But they ate 9. So if I write 1, 2, 3, 4, 5, 6, 7, 8, 9,
Well, that's a good way to do it, Camden. See that drawing?
that's how many pieces they ate. So there are 12 pieces, correct? Because it's 6 and 6, and they ate 9 out of 12.
There's your fraction.
Or wait, now.
But in terms of
yeah,
pizzas,
let's think about this again. 9 out of 12 pieces, but let's get the end of that question again to make sure I'm answering it correctly. What does it say at the end of the sentence?
It said, what fraction of pizzas did they eat?
Pizzas, okay. So I'm looking at slices. We don't want to do that. We want to look at pizzas. So how much of that first pizza did they eat? All of it. They ate 6 slices out of 6.
so that's 1.
Or 1, that's right. And then on the other pizza, how many pieces did they eat? They ate 3 slices
Yes.
out of 6. So if we reduce those fractions, we can think of that as 1 6/6 plus 3 over 6 reduces to, you know how to do that, right?
What did you say again?
Do you know how to write the fraction 3 over 6 a different way? Because 3 and 6 can both be divided by 3? Or maybe I should say that differently. Another way of looking at that is if I look at this picture, what part of the pizza did they eat? If they ate these 3 and didn't eat those 3, what could you say about the pizzas that they ate? They ate half the pizza?
Yes.
Can you see that?
There you
Because
go.
they ate 3 pieces out of 6. So it's really 1 plus a half, also known as 1 1/2
Pizza.
pizzas. Does that make sense?
Yes.
That and Mrs. Diggle drew those pictures, Camden. That really is helpful. Whenever you read a math problem, if you read the problem and then draw a picture and then label it, a lot of times the answer comes right to you.
Yeah. And in fact, even if the problem isn't about pizza, pizzas are a great help when you're doing problems about fractions. Because it's easy to think about, I ate half the pizza, or I ate,
Or pies or
a
any
piece
of that.
of the pizza, right? So I find pizza very useful.
Camden, you got another question at all?
No.
No.
Well, thank you so much
Thanks
for
for
calling in.
calling.
And what school do you go to, Camden?
Winslow?
Oh, good place.
Wonderful. Great.
All right, well, good luck on the rest of your homework.
Okay, bye.
Bye-bye. I'm so glad he got in.
Yeah, he tried to call the other day.
Yeah, he was the one having trouble either with the connection or with something. And and we were wondering what his question was.
Oh, well, good. I'm
But
glad
that
we
was a
straightened
good
it out.
math question.
Yeah, it was.
I thought it was really interesting that Elise called in about the water cycle.
I know.
Because that was the very thing we were going to do
That's right.
if we had a lull
Quiet time.
in the class. Yeah. So why don't I do a little of that now, since Elise might find that of interest. Okay, can we go to the Elmo?
Want black?
Yeah. Okay, so what I'm going to outline here for you guys is why it's raining out. You know, it's pouring out right now.
It's terrible.
Before I get started, I think we might have another call. Wait, hang on.
It looks like we don't.
Is it going to be Adrian?
Adria.
Adria. Adria, are you there?
No, Adriana.
Adryana, are you there?
Yeah.
Oh, hi, Adryana. What grade are you in, Adryana?
4th grade.
4th grade. What school?
Winslow School.
Oh, our favorite little school that calls in.
Good.
So, Adryana, did you leave us a message?
No.
Okay, that was someone else. What do you got for a question in math?
How do you, do double-digit multiplication, 24 times, 28 or something?
Oh, that's great, giving us an
Okay.
example. That helps us know what the question is. So, Mrs. Diggle will do this. Look on your screen, you'll see her do it. 24 times 28.
All right. Now, Adriana, sometimes when you learn something in school, you might learn it a little differently from the way we do it. And that's because there's sometimes more than one method. But I'm going to use the method that most people use, which is this. What we normally do is write the two numbers, one above the other, and then what you do is only look at one of the numbers in the bottom row. We start with the number on the right, the 8. And we do the multiplication as if that 2 wasn't even there. We say, what's 8 times 4? And so, Adriana, you can tell me, what's 8 times 4? Can you hear me?
32.
Very good.
Good
All right.
girl.
So what I do is write the 2 and carry the 3. Now, we usually write it up above, so we'll remember it for a few minutes. And then we do the next multiplication, 8 times 2. Forget the 3 for a moment. 8 times 2 would be how much?
16.
Right.
Good
But
girl.
now we have to add on that extra 3 that we saved. So what's 16 plus 3?
19.
All right. So I'm going to write the 19 here. Now that's the first row of my multiplication. But now we have to do the second row of the multiplication, and sometimes this causes students a little bit of trouble. I know you're in the 4th grade, so maybe you're past this already, but I know sometimes students are told to make kind of an X or a box over here.
Or even a 0, they've been told.
Yeah, or a 0, to make sure that they don't write in this position. I'm going to put the 0. I think that's a good idea, Mr. Goodfellow. Just so we don't fill in that spot, because we really start writing our numbers under the 9. And then we start doing the same multiplication over again. Forget about this 3, we've already used it. And now we're going to ignore the 8 and multiply by 2. So we're going to say, what's 2 times 4? And that's what? How much is 2 times 4?
8.
8.
Good.
I write the 8 under the 9, but not over there. That's the problem a lot of people have. And then I have one more to do. I have to say, what is 2 times 2? And that would be
4.
4.
Good.
That goes under the 1. And then we draw a line, and now we add. Even though this is a multiply problem, we end up adding. 2 plus 0 is how much? 2 plus 0? 2, good. Now how about 9 plus 8?
17.
17. So I write the 7, carry the 1. I'm going to write it up there so I don't forget about it. And then I'm going to add 1 and 1 is 2, and 4 is 6. So I'll
6.
write the 6 here, and that should be the correct answer, 672.
And that's how you do it all the time.
All the time. Now, you know, that brings up something I told Mr. Goodfellow we might do today. Maybe I can take a minute to show you this little quick trick I have, Adriana,
Okay.
for checking multiplication. Because sometimes you're just not sure if you got the right answer. So this is, I don't know if you've seen this before, Mr. Goodfellow,
Well,
but
let's
it's
see.
kind of an interesting trick. What you do is go back to the original problem. You see where there's a 2 and a 4? Add those numbers together. What's 2 plus 4? 6.
6.
I write the 6 over here. What's 2 plus 8? 10. But then, in your head, can you picture that 1 and that 0? Add those numbers together. 1 and 0 is 1.
1.
So what you do is add the separate digits together till you get just one digit. 2 plus 4 is 6. 2 plus 8 is 10. 1 plus 0 is 1. Now, if I multiply those two numbers, 1 times 6 is 6. I can check my answer by taking the answer that I got and checking to see if I add these digits together, does it also give me a 6? Notice 6 plus 7 would be 13.
Yes.
And 13 plus 2 is 15. Now, can you picture the 1 and the 5? What happens when I add them together? 6. And that's a good way to check that I did it right, because if those two 6s match, chances are my answer is correct.
I've never seen that before, Adryana. Never. I haven't seen that thing. That works all the time?
It always works.
Wow.
It's kind of a cool little trick for checking
Yeah, my teacher taught me like the lattice method, but with that way I get kind of confused sometimes.
So, yeah, there are different methods, you're right. But this little checking thing is a nice little trick if you can remember it, because like if you're taking a test or something in class, it's a quick, easy way to see if you've gotten the right answer. Yeah.
And Adryana, what's really important when doing multiplication is knowing your multiplication tables.
And it sounds like she does. She's pretty good at that.
You did really well with
Yeah.
it. But when people haven't memorized their multiplication tables, they usually get in a lot of trouble trying to do complex multiplication.
That's right.
Do you have another problem, Adryana, you want to do?
Not really.
All right.
Well,
Thank
good.
you for calling in, dear.
Thank you for calling.
And good luck on your homework. Oh, and by the way, I meant to mention that when you call in, Cynthia Goodfellow is on the phone. She's a teacher as well, and she helps you form your question and understand what you're trying to ask, and then she sends it in to us on a little monitor that we read, and that's how we know who you are.
That's right.
So don't be afraid to call. She'll help you phrase it correctly so that you'll be okay when you're on TV.
Nice. I think it's interesting that you've never seen that checking
No, I never
method
did.
before. It's actually called casting out nines. There's a bit more to it than that.
Yeah.
But it's just such a quick, easy way to
Now,
check.
this will work for any number of numbers. If I multiply 3 numbers times 3 numbers, is it going to work?
Well, usually you don't multiply 3 numbers.
No, I mean, if I had 111 times 478.
It doesn't matter how many digits you have. It
How
always
about that?
works. Yeah.
Yeah, of course, I would have trouble remembering it, I think, the checking procedure.
Well, it's easy enough. Just add across till you get one digit, and then you do the multiplication problem with one digit.
Yeah, and students, we should say, the things with mathematics is you need to practice.
Yeah.
Because a lot of things you have to remember, and you can't remember unless you do over and over again. We have Soraya in the 4th grade with a math question. Soraya, are you here? Soraya?
Hello?
Hi. You have a math question?
Yeah.
You're in the 4th grade. What school? Soraya, what school do you attend?
I hope. Are you still there?
Yeah, but they said my name wrong.
Oh, how do you
Oh,
say
I'm
it?
sorry.
honey?
Say it for us.
Haley.
Kaylee?
Yes.
Oh, okay.
Kaylee.
Okay, Kaylee.
That's not what was on the monitor
we're
there.
reading something different there. I'm sorry, but okay, Kaylee.
All right, we got it, Kaylee. What school are you at?
Winslow.
Oh,
Yep,
good. All right.
excellent. Okay, so you have a math question.
Yes.
Can we hear it?
Sure.
Go ahead.
Oliver earns $4 a day for 7 days for doing chores. Each day, his mom takes out $2 and puts it into a savings account
Good mom.
for Oliver. How much money does Oliver get to keep after 7 days?
Perfect.
Okay, now let me see if I've got this straight. It sounds like he makes $4 a day for 7 days. Is that correct?
Yes.
And then his mother takes out just $2 or $2 every day?
It just says she takes out $2 and puts it into a savings account.
Okay.
Probably each day.
I don't know. It could. Yeah, that's it. Okay, so that's. If it doesn't say each day, I wouldn't assume that. But let's just start from the beginning. If He makes $4 every day for 7 days. What are you going to do with the 4 and the 7 to figure out how much money he made?
Multiply it.
Exactly
Absolutely.
right. So if you multiply 4 times 7, what do you get?
28.
Perfect. Now, if his mother just took out $2, what would you do with the 28 and the 2?
Minus it.
Yeah. So what would you get? What's 28?
26.
26. Now, I think from what you said that that's how much money he would get to keep, the $26. But it depends on how that question is stated. So you might have to read it again carefully to see. It says he makes $4 a day for 7 days. The mother takes out $2 for his bank. But it didn't say she took out $2 every day.
Well, what's the final question, Kaylee?
It says, how much money does Oliver get to keep after 7 days?
Yeah.
Yeah, see, it's either 26, like you just did, Kaylee,
Right.
or if she's taking out $2 per day, which is what I would guess the question would
Yeah.
be, then it's 2 times 7, which is $14 she took out.
And he keeps the other 2 times 7, which is the
Right.
other $14. Yeah.
Do you see that, Kaylee?
Yeah, I think it's every day.
Okay.
Yeah.
Well, then I think Mr. Goodfellow's right. So what happens is, if you think about it, if he was making $4 a day and mom is taking 2, that's 2 times 7 for the bank and the other 2 times 7 for him.
And we should show Kaylee how to diagram that, because in all math problems, Kaylee, if you don't write down what's given and sort of try to draw a little scheme, a little diagram, you can get confused quickly. Even we can. So Mrs. Diggle's putting it on the Elmo right now. See, it's $4 per day times 7 days.
So you could multiply 4 times 7 equals $28.
So we made $28 in the 7 days. That's the total amount of money he has
But if $2 is going in the bank,
per day.
that would be 2 times 7 would equal $14 for the bank.
That's after 7 days.
Yep.
And then if you subtract the 14 from the 28,
And now you got 14
you're going to get the other 14
that he gets left over.
to keep.
Yep.
And then you can also write down how generous his mother is. That's great.
That's smart.
Half the money.
Because that way he can save that money for something else he wants special later on.
You okay now, Kaylee?
Okay,
Yeah.
I think Mr. Goodfellow is right. I think I'm going to go with your idea. That sounds like the right way to do it.
And remember, when you do these math problems, please try to write what's given on a piece of paper before you even think about how to solve it, because it really helps you get it organized. Okay?
And you have to
Okay.
Thank
be
you
real
for calling,
careful
dear.
when you read the problems to make sure you've got all the details.
Right.
So
Thank
can
you.
see it
Yeah,
there.
you're welcome.
Thanks so much.
All right, now we have Soraya, 4th grade, with a math question. Soraya, are you there?
Yes.
Hi.
Good. We finally got to you.
Can we help? We don't have much time left, so we're going to have to go quick.
What do you got for a question?
Lexi subtracts 9,405
9,405
11,138
from
Should her
11,138.
Should her answer be greater than or less than 2,000?
Gotcha.
Explain.
So
Greater
on the
than
Elmo, if you look at your TV screen,
or less
Mrs.
than.
Diggle is going to do that problem for you.
Now, just for the question, greater than or less than, did you say 2,000?
2,000.
All right. Now, I'm thinking that they don't want you to actually do the subtraction.
We're going to be out of time in
But
about
to think about
5
it.
seconds.
Yeah, we're going to have to stop pretty quick. But the idea is if it was just 9,000 from 11,000, it would be exactly 2,000. Whoops, and we have to stop.
Oh, we'll see you later. Sorry we couldn't get to everybody's
Sorry, we'll try to
call
get
in
to
again
another day.
tomorrow. Call in again tomorrow.
Tuesday.
Soraya particularly.
Actually,
I'm
Tuesday.
sorry, Tuesday.
Yeah.
Particularly Soraya, who we didn't get a chance to finish. Thank you all for calling in.